Exercise 2, Chapter 2, Exercise 37. Show that for all sets the following equations hold. A union B minus C is equal to A minus C union B minus C. B, A minus B minus C is equal to A minus B union A intersect C. And C, A minus B minus C is equal to A minus B union C. Alright, strap on because this one is going to take a while. It's just long, it's not too difficult. Yeah, this is standard these two sets are equals proof. And yeah, there's not much to it other than that. So let's suppose X is in A union B minus C. Then X is in A union B and X is not in C. So X is in A or X is in B or, alright, sorry, and X is not in C. Alright? Because that's what it means for, oh, I always forget. Even though it's kind of a given, you have to add the or both. Okay, and X is not in C. So in the case that X is in A, we have that X is in A and X is not in C. So X is in A minus C, and thus X is in A minus C union anything, and yeah, it's supposed to be B minus C. Cool. So that's one. Now on the other hand, if X is in B, then X is in B and oh my god, X is not in C. So X is in B minus C, and thus X is in A minus C union B minus C. Writing on paper is so much nicer than writing on the tablet. This is going to give me carpal tunnel. Okay. In the case that X is in A and X is in B, X is in A minus C and X is in B minus C, so definitely. So rather, union B minus C. There. Okay. All this to say that A union B minus C is a subset of A minus C union B minus C. There we go. And how did I do this time? Now suppose instead that our good old friend X is in A minus C union B minus C. Then X is in A minus C or X is in B minus C or both. Now if X is in A minus C, X is in A and X is not in C. X is in A, as we all know, implies that X is in A union B, which or rather, let's just do one inference per line. Therefore, X is in A union B, and X is not in C, so it must be true that X is in A union B minus C. Okay. I need to rest my wrist. Going too hard on the math. Okay. If X is in B minus C instead, then X is in B and X is not in C. So X is in B implies that X is in A union B. By the same reasoning, X is in A union B minus C. If X is in A minus C and X is in B minus C, then clearly X is in A union B minus C, because both cases apply. Okay. Therefore, X is going to be in A union B minus C no matter what. Meaning that A minus C union B minus C is a subset of A union B minus C. We conclude that A minus C, rather, to put it as in the problem statement, these two sets are equal to each other. There. Cool. That's one. Now, part B. I'm just glad this chapter is almost over. I am so tired of these proofs. They're so boring. I forgot what I was supposed to write down. Okay. Wait, I have the book right next to you. I'm so dumb. 1 second. Where are you? Okay, here. Right. A minus B minus C is equal to A minus B union A intersect C. Okay. Suppose X is in A minus B minus C. Then as usual, X is in A and X is not in B minus C. So X is in A, and it is not the case that X is in B and X is not in C. Thus, X is in A and X is not in B. So I was about to use the other symbol. Or X is in C. Okay. Right. So, again, we just used De Morgan's laws for logic here to push in this negation and then change this and to an or. And I encourage you to verify that this is indeed a valid inference yourself. It shouldn't be too difficult. Okay. So, if X is not in B, then X is in A and X is not in B. Crazy. So X, alright, rather, let's just move it down here. So X is in A minus B, and thus X is in A minus B union A intersect C. Otherwise, if X is in C, then X is in A and X is in C. So X is in A intersect C. which directly implies that X is in A minus B union A intersects C. Okay. Cool. So there you go. That's one side. So what set did we get this from? Oh, the book closed. No. Stop. Here. So A minus B minus C is a subset of A minus B union A intersects C. Okay. Now, suppose X is in A minus B union A intersects C. Then X is in A minus B, or X is in A intersects C, or both. Okay. If X is in A minus B, then X is in A and X is not in B. Now, since B minus C is a subset of B, if X is not in B, then X is not in B minus C. So X is in A and X is not in B minus C. So X is in A minus B minus C, which is crazy. Okay, and if X is in A intersects C instead, then X is in A and X is in C. Right. If X is in C, then X is definitely not in B minus C. So X is in A and X is not in B minus C, meaning that X is in A minus B minus C. So, which side of the inclusion are we on? Oh, right side. So A minus B union A intersects C is a subset of A minus B. Thus, the two sets must be equal. Cool. Phenomenal. And now we have part C, which, according to the book, is A minus B minus C equals A minus B union C. Oh my goodness. Alright. Let's get through it. X is in A minus B minus C. Then X is in A and A minus B and X is not in C. So X is in A and X is not in B and X is not in C. Since X is not in B and X is not in C, X is not in B union C. So X is in A and X is not in B union C. So X is in A minus B union C. Cool. And there's no cases to think about. I like that. Ow. Right. So, let's see. Thus, no, not X, but rather A minus B minus C is a subset of A minus B union C. Cool. And on the other hand, I need to get new transition sentences. These are getting outdated. On the other hand, if X is in A minus B union C, then X is in A and X is not in B union C. So, or rather, since X is not in B union C, X is not in B, and X is not in C. So, X is in A and X is not in B. Thus, X is in A minus B. So, X is in A minus B and X is not in C. Thus, X is in A minus B minus C. Therefore, consequently, I need to get more creative. Consequently, what was the set again? A minus B union C is a subset of A minus B minus C. So, we conclude, what's a different conclusion? In sum, A minus B minus C is equal to A minus B union C. Alright, cool. And I think that's all of them, which is phenomenal. Yay. Okay, we got through the second to last exercise. We have one more to go, and then we're done, finally, officially, with chapter 2. We can move on to the fun stuff, such as, let's just take a look at relations and functions, ordered pairs, what else? N-ary relations, that's crazy. At least there's pictures on this chapter. They look pretty okay. There seems to be more content, more interesting content on chapter 3. So I'm looking forward to that. Anywho, I hope this video was helpful, and I will see you in the next video. Bye-bye.